1 minute. The cells can be of two types, right? The cell can be primary cell, right? On primary cell. Hmm. The cell can be secondary cell. Is it clear? Understood, everybody, right? Cells can be of two types, right? It can be primary cell, it can be secondary cell, right? Isn't it? Now over here, what's the primary cell? Primary cell is a cell, or we can tell the voltaic cell can be two types: primary cell, secondary cell. A primary cell cannot be recharged, right? Cannot be recharged, right? Fine, understood. What's a secondary cell? Secondary cell is a cell which can be recharged, right? Clear? Understood this part, right? Can be recharged, right? Primary cell is a cell which cannot be recharged. A secondary cell can be recharged, right? Clear? Now, now if you think the basic, if you think the basic cell, right? The cell which we are using, right? The cell which which we are using in our home, right? This the all the batteries, right? All the pencil batteries, right? So you have to see that the reaction will be going. You can go over this, right? This is not difficult, right? Is it? That at the zinc, at the zinc, what's the reaction happening? We're having that oxidation happening, right? So see in this cell, what is happening? You're taking the carbon rod over here, and we're taking a paste of manganese oxide and powdered carbon over here, and we'll take a ammonium chloride paste, right? Isn't it ammonium chloride paste, right? This will be acting as what? This will be acting as a cathode. Write down this, right? Cathode, right? This bit, huh? This bit will be acting as a cathode, right? And what is acting as an anode? The zinc will be acting as an anode over here, right? Fine, right? Now, I just write down this trick quickly, huh? Write down this trick. In a very shortcut, I'm telling you that if you have got zinc, and if you have got, suppose we have got copper, right? Just know this part: the more reactive element, that also you can note down, the more reactive element we take it at the anode. Please note down this, right? Fine. In the voltaic cell I'm talking about, right? You can note down this. The less reactive metal we take at the cathode, that will be helping a lot, right? In quickly doing it, right? See, we're having zinc over here and this ammonium ion. So zinc will be taken at the as a anode, right? Fine. So you're getting this zinc 2 plus plus 2e. Now in this is the cathode we are having, this whole bit, right? What happens? Zn2 plus plus 2e gives you ammonia plus H2, right? Isn't it? So actually overall the cell reaction, what you do, you add up this reaction, what I tell, right? It's very easy. Next of all, we are getting this, right? And what we are getting, the cell potential as 1.5 volts we are getting, right? Now we are you can go through this, right? This lead acid, lead acid per battery in the petrol car or the diesel cars, we're having this battery, not in, right, in the hybrid cars also we have got. So this is a basic cell which is used in the cars, right? Isn't it? So if you see that at the anode, right, at the anode, we take what? We take a lead plate, right? Isn't it? Now, at the cathode also we take a lead plate, right? Lead plate, but lead plate is coated. This is very important. You can write down at the you can write down positive plate or negative plate. That'll be better, right? I forgot to tell you, right? Just note down this. In the batteries, you don't you it's always better to write down positive electrode, negative electrode, right? Now at the positive electrode, we take what? The positive electrode, we take the lead plate, and this reaction happens. And what we take a lead plate at the electrode, and lead plate with lead dioxide coated, right? At the cathode we are taking, right? And we are taking H2SO4 as an electrolyte, right? Isn't it? So Pb plus SO4 2 minus gives you PbSO4 plus 2e. These two electrons will be going via the external wire and coming to the reduction cell, right? What happens over here? Lead oxide is coated, right? Lead dioxide, right? So lead dioxide plus 4H plus SO4 2 minus give plus 2E gives you PbSO4 plus 2H2. This is a very important thing. How to remember? In the both the cells, the PbSO4 is generated. You can write down this, right? In the both the cells, the PbSO4 is generated, and in the both the cathode and the anode, right? The PbSO4 will be actually generated, right? Clear? Is it clear to you, right? Just 1 minute, guys. Just give me 1 minute, right? Just 1 minute. Reaction. This is discharging reaction. When the battery discharges and you put the headlights and you put so you can hear the sounds, music and all. What's the charging reaction? Could you know that?
I don't think so.
It is just opposite of it. Please write down this. It is written over here. See, the reaction is reverse when it's charged up.
Oh,
You get my point? Please write this down. It's not given in your book, but questions come, right? Do you understand? This is discharging reaction, guys, isn't it? Discharging reaction. Discharging reaction. This is underline. Have you underlined it? Tiara,
mhm,
have you underlined it? The positive plate consists of lead coated with lead oxide, and the negative plate consists of lead, and it
mhm.
is dipped in the sulfuric acid. Have you written?
Yeah.
Given? Thank you so much. You have to just add. These are discharging reaction, guys. You have to just flip this reaction to get the charging reaction, right? Fine. Is it clear? See the lithium ion battery, right? This you can go to the nickel pearl cadmium battery. So these things are you to just memorize. That's all, right? This memorize, right? The nickel cadmium batteries are much more expensive, right? Because they can be recharged up to 500 times, right? Isn't it? And nickel cadmium batteries are used in toys, right? Mainly they are used in toys, right? As per the cell potential is needed, right? So just go through this, right? Just go through these equations. You have to memorize it, right? Just know that this is a very special kind of compound we have come across, right? We never come across this compound, right? So just learn this. I want to go through it, right? Just go through this and memorize it, right? Same is the lithium ion. Lithium ion will be having what? Will be having a very light. They are very much light, right? So they can this lithium ion batteries in your laptop, in your cell phones, right? In the Tesla cars, right? What happens over here? We are taking the negative electrode, and it is getting what? We are getting what? A reduction reaction at the negative electrode. Li plus E gives you Li, and Li plus CO2 plus E gives you this. You have to memorize this, right? This is a charging. Please underline this. Underline the charging. This is not discharging, charging, right? Charging. Just opposite. Means they actually did not follow the trend over here, guys. This is the discharging equation, please. All are discharging till now. And we have to reverse it for what? We have to reverse it for the charging reaction, right? Understood? Anyways, this hydrogen fuel cell also, can you tell me saying that what is the disadvantage of the hydrogen fuel cell?
You need a constant supply of hydrogen gas.
No, not really. We can take it in cylinders, and we can fill the cylinders and constant supply.
Oh, is
That's
it?
a positive part, that you don't have to recharge this cell. The constant supply will be there, and this can be cell can become in different forms and sizes. What's the negative point of this? Anybody can tell me. The negative point is what? There's hydrogen. This
Is
hydrogen
it
is
like
extremely
flammable?
inflammable, right? Extremely inflammable. And it's very difficult to store and transport, right? A very minor spark can blast off the entire cylinder. Understood? Most important, hydrogen till now is obtained from electrolysis of water. What does electrolysis of H2O does? It needs electricity. Did you get my point? In the hydrogen fuel cell, this is the most one. Do you know what? In any time, this hydrogen will be sourced as a cleaner way, right? In a greener way. It will be changing the game. You have got hydrogen fuel cell cars also, right? You have got the Toyota also, right? But
Mhm.
hydrogen gas stations are very less. But if you get hydrogen from a much more cleaner source, why? Till now we are sourcing this hydrogen from a electrolysis of water. We are electrolyzing water. That needs what? Electricity. And electricity comes from where? Can you get me Sigda? Mainly from where? 90% of electricity comes from where? From burning of coal. Understood?
Mhm.
The
Mhm.
coal will be releasing carbon dioxide. Why?
Mhm.
Can you tell me that what do we why? What's the plus point of this cell? They're actually giving out H2O,
Yeah.
a harmless product. In the
Mhm.
cars, buses, aircrafts, what is happening? Oxidation. You're getting the combustion reaction. Understood? I
Mhm.
got again carbon dioxide plus water. This carbon dioxide is a greenhouse gas. And also internal combustion engines such as petrol, diesel, they'll be releasing sulfur dioxide, nitrogen dioxide. This is acid rain occurs, right? These questions also will be coming up. So this is does not obtained in the hydrogen fuel cell. See, it's a cleaner product. But the main worry is that hydrogen is very difficult to transport and take, right? First. Second, hydrogen till now is obtained from very is obtained from the electricity of water that needs electricity, needs burning of coal, and 90% of the electricity is obtained from burning of coal, right? Clear? This is clear to you? This is an alkaline hydrogen fuel cell. If you can recall, in your GCSE, you had the proton means the acidic fuel cell, right? Isn't it? Is it
Mhm.
clear, everybody? You get my point? These two are the reactions. We are pumping in hydrogen from the negative electrode. What happens? It will be combining with the OH minus and alkaline hydrogen fuel cell, right? There's alkaline, right? We're getting this H2O plus 4E. This 4E will be getting transferred by the external wire and coming to the positive electrode, and where oxygen is getting pumped in. So what happens? Oxygen plus H2O plus 4E gives you 4 OH minus. See, the OH minus generated over here will be passing through the to the semi-permeable membrane, right? And again coming to the negative electrode to be used up, right? So you don't have to supply the NaOH, right, over K or KOH. Do you get my point, right? What happens over here, right? Is it clear to you? Fine,
Mhm.
fine. So this is the thing you have to just go through, right? Fine. So just to go to the theories part and of this reaction part, you practice over that, right?